Now suppose you were God and wanted to create a universe just like ours. How would you do it? Turns out it's a lot easier than you might think. That's because the fundamental design of the universe is really quite simple. In this talk, we'll explain that fundamental design, which is also called the theory of everything. So if you were God, how would you start? First, you'd write the universe as a program that would run on its own, so you wouldn't have to make everything happen yourself. Second, you'd need a special computer to run the program that would compute a real universe instead of a simulated universe. So you'd need to invent a universal computer called the quantum vacuum that would make everything the program computed real and actual. The quantum vacuum also requires a processor to run the program, and this processor will be the ultimate source of time that makes everything happen. And because the quantum vacuum exists, it must have presence, and its presence will manifest as a universal present moment in which the entire universe exists. Okay, we have a computer, so now we just need a program to run in the computer. We need a program that creates a virtual reality that looks exactly like our universe and run it in our quantum vacuum computer. This will make the virtual reality into a real, actual universe. Now, a virtual reality is just a program computing data in computer memory. A computer memory is a dimensionless computational space. Its apparent three-dimensional physical reality only appears when we view the data in a virtual reality headset that displays it as colored pixels in three-dimensional form. So we design our universe in the exact same way. The universe will consist of particle data in memory. There will be a program that continually computes this data, and it will be our minds acting as headsets that view the results as a three-dimensional world. The observable universe is just the data of all the elementary particles and their relationships. So a relatively simple program that computes individual particle interactions is all that's needed to compute the entire universe. This works fine because everything above the particle level is an emergent structure that's actually just relationships among particles viewed in aggregate. Emergent structures include dimensional space-time and all objects made of particles, including ourselves. Think of particles as the colored pixels in a virtual reality headset. A viewer doesn't see individual pixels, but he sees the relationships among pixels as moving objects in a three-dimensional world. The virtual reality emerges from the relationships among pixels in aggregate. So all that's needed to create an entire universe like ours is just the data of individual particles and a relatively simple program that computes their interactions. This is what makes the universe so easy to create. Now, the data of the elementary particles is mainly the data of their particle components. The particle components include identity, for example, quark and lepton numbers, their various force charges, including mass, which is the charge of gravitation, spin, and temporal and spatial parity. Numeric particle positions and velocities in memory are also stored so that particles of the same type can be distinguished and total energy and momentum can be conserved. Now, all the elementary particles are just valid sets of these few particle components, and the precise values of the particle components are part of the complete fine-tuning. The complete fine-tuning is all the fundamental values, data types, data structures, data manipulation operators, and everything else used by the elemental program to compute the universe. The complete fine-tuning is all part of the program that computes particle interactions. We have to be sure to set the complete fine-tuning to the precise values it has in our universe because it's this small set of values that determines the entire emergent structure of the universe. These are the basics. So to start the universe running, we just actualize a bunch of elementary particles to make a big bang, and the processor automatically begins computing the entire universe from their interactions. So how do we design our program to compute particle interactions? Basically, whenever particles have the same x, y, z, and t locations in computer memory, our program computes an interaction which can be either the particles scattering off one another, combining or splitting to form new particles, or forming bound relationships to create atoms and molecules. What happens depends mainly on energies and whether all particle components can be conserved among resulting particles. There can't be any unused particle components left over outside of particles. In all interactions, the main thing the elemental program does is conserve all particle components, including energy and momentum. The total of each particle component exiting any interaction always equals the total entering the interaction, with only a couple of rare exceptions. Interactions often change particles into new particles, but total particle components are almost always conserved. This is why the particle components are the fundamental components of the universe rather than the particles. Total energy and momentum are also conserved in every particle interaction, which is why nominal positions and velocities must be stored in memory, just as they are in a virtual reality. Now, because particle components are conserved, the particles exiting an interaction are entangled. Entanglement just means that particle components have related values. All the particles exiting an interaction will be entangled on their particle components. Entanglement is easy to understand because it also works with cookies. If we break a raisin chocolate chip cookie into two pieces, the two pieces become entangled on their raisins and chocolate chips because the total in the two pieces equals the total in the original cookie. So entanglement and conservation are simple, fundamental principles that hold at all levels. Now, all the particles in the universe are part of a single network of interactions dating back to the Big Bang. This means there are some relationships among all the particle components of all the particles in the universe. These relationships form a universal entanglement network of all the relationships of all the particles in the universe. We humans see these relationships among particles as all the emergent forms of the universe, including dimensional space-time. The physical universe we seem to see around us is our mind's simulation of the relationships of the entanglement network at an aggregate level. However, we're actually viewing a reality that consists entirely of particle data in quantum vacuum memory. Our minds have just evolved to see it as an encompassing physical world, which makes it a lot easier to relate to. Now, we've already created a perfectly good Newtonian universe, but we're missing relativity. Luckily, there's a simple way to add it. We just have separate applications of the elemental program simultaneously compute every separate coherent process using a fixed number of processor cycles, so the total space-time velocity of every process is equal to c, the speed of light in a vacuum. First, processor cycles are used to compute any spatial velocity, and then all remaining cycles are used to compute the internal evolution of the process, which produces its velocity in clock time. In this way, the total space plus time velocity of every process in the universe is computed to equal c. This is the fundamental principle of relativity. So the source of c, the speed of light in a vacuum, is simply the fixed number of processor cycles used to compute processes in every tick of processor time. As a result, there are two separate kinds of time. Processor time, which manifests a new universal current present moment at each tick, and the local clock time rates processor time computes, which all depend on the local amount of spatial velocity. And we actually experience this fundamental process of the universe as our consciousness of a present moment through which clock time flows. Now, to include general relativity, all we have to do is make mass and the other force charges be fields of intrinsic spatial velocity, so they slow the clock time of processes in their fields. Each of the four forces is a different form of intrinsic spatial velocity. In particular, masses are fields of hyperfine vibrations, and positive and negative electromagnetic charges are fields of hyperfine clockwise and counterclockwise helical rotations that either reinforce or cancel each other out. So the charges of the four forces are all different forms of intrinsic spatial velocity. This means that energy itself is simply spatial velocity. Masses and all types of energy are just different forms of spatial velocity, and all forms of spatial velocity are types of mass energy. Spatial velocity is mass energy, and mass energy is simply spatial velocity. They're the exact same thing. Only this simple equivalence explains why mass energy can be conserved. Different forms of energy can only be converted into each other and conserved if they are different forms of a single thing, spatial velocity. With this simple addition, both special and general relativity automatically become part of our universe. The universe itself is now a single universal field of c-valued velocity, which can be either velocity in time or some form of velocity in space, which is always some type of mass energy. So the entire universe is a single field of c-valued velocity produced by the cycle rate of the processor that computes it. This is an enormously profound and important fundamental realization completely missing from current science. Okay, we've now created a universe that naturally incorporates relativity, but we still need to give it quantum nature. This is also easy. We just have the program randomly mix up or conflate a small percent of spatial and temporal velocities as it computes each coherent process. A coherent process is a particle interaction and all the particles produced by that interaction prior to any subsequent interactions. All coherent processes are simultaneously recomputed in every tick of processor time, and each coherent process is computed by a separate application of the elemental program. So there's a separate app computing each coherent process, and each app computes its process with a different, unique random conflation pattern. This simple addition is all that's needed to give the universe quantum nature. Each app computes the total space-time velocity of its process with the same fixed number of processor cycles. This gives every process in the universe a total space-time velocity equal to c. However, as each app computes its process, it randomly conflates a small fixed percent of the space and time cycles, and each app does this with a different unique conflation pattern. Cycles that should be used to compute spatial velocity are used to compute velocity in time, and vice versa. This simple addition immediately gives us the dimensional indeterminacy of the quantum world. It gives us a universe in which it's impossible to simultaneously measure spatial and temporal variables with greater than Planck constant accuracy. It gives us the Heisenberg uncertainty principle. And it also makes particles act like wave functions because their dimensionalities become inherently indeterminate at the quantum scale, which is simply the scale of conflation. So just having the elemental program compute everything with a fixed number of space plus time velocity cycles at the relativistic scale, while it randomly conflates them at the quantum scale, adds both relativity and quantum theory to our universe with a single, simple mechanism. And this simple mechanism also unifies relativity and quantum theory because particles act like wave functions at the quantum scale, but are scaled by the presence of mass energy as they're computed, and this results in the curvature of space at the relativistic scale. So quantum equations still work as before, but they now have a minute additional term that scales them by the presence of mass energy, which is negligible at the particle scale and only becomes apparent at the relativistic scale. Now wave functions have indeterminate dimensionalities, but for interactions to take place, Particles must have exact mutual dimensionalities. In particular, they must have exact energies with respect to each other, so mass energy can be exactly conserved. This occurs through decoherence. When particles from separate coherent processes interact, they leave their previous apps and a single new app fires up to compute their interaction. This new app begins by randomly selecting exact mutual dimensionalities from the wave functions of the particles so mass energy can be conserved. This selection of exact dimensionalities from wave functions is called decoherence. Only by making the particles exact with respect to each other can mass energy be conserved and their interaction be computed as a new coherent process. This new coherent process will then be computed with a new conflation pattern by the new app. Now each coherent process is effectively a dimensional fragment consisting of the coherent dimensional relationships among the particles produced by an interaction. So the universe consists of myriads of dimensional fragments that are indeterminate with respect to each other at the quantum scale, but whose dimensionalities are exactly aligned by decoherences whenever particles interact. This creates an emergent spacetime that's dimensionally indeterminate at the particle scale, but exact at the relativistic scale. So spacetime is an aggregate view of the dimensional relationships formed by the conservation of mass energy and particle interactions. Particle interactions create dimensional fragments, which are stitched together by subsequent particle interactions to create new dimensional fragments, and so on, to include all the particles in the universe, including those in the bound interactions of atoms and molecules. These particle relations are what we and other species see as a physical universe in a physical space-time. But it's really all just the relationships among the data of individual particles. Only beings able to see particle data relationships in aggregate are able to see an emergent universe. In this respect, the universe works exactly like a virtual reality. This model effectively reproduces quantum reality at the particle scale and relativity at the classical scale when the dimensional relationships among particles are scaled by the presence of mass energy as they are created. The great beauty of this model is that it not only unifies relativity and quantum theory, but also resolves all quantum paradoxes, because quantum phenomena are paradoxical only with respect to a pre-existing physical spacetime that doesn't actually exist. For example, the standard spin orientation paradox is no longer paradoxical. The equal and opposite spin orientations of two particles are created by a particle interaction and exist as part of their single dimensional fragment. When the spin of one is measured, it automatically aligns that entire dimensional fragment with the dimensionality of the measuring device. Thus, a measurement of the other spin will always find it with the opposite orientation. So quantum reality isn't paradoxical at all when we understand that spacetime is emergent and created by particle interactions. It only seems paradoxical with respect to a pre-existing spacetime that doesn't actually exist. So there's no faster-than-light communication between particles, and since there's no pre-existing spacetime, everything is automatically non-local. So non-locality is natural, not paradoxical. So what we see as a physical spacetime world is just our view of the implicit dimensional relationships among particulate objects at an aggregate scale. The physical universe emerges from the relationships among particle data. It's not an actual physical structure. All right, we just created a universe like ours and it only took us 20 minutes instead of 6 days. I think God deserves a good long rest from his labors. And once we start the processor and fill this universe with particles, all the rest of our universe emerges automatically as particles interact over billions of years to create all the emergent structures we see in the universe today. All these emergent structures are described in my books and other deep reality talks and don't need to be repeated here. However, the universe that emerges It won't be exactly the same as our current universe because all particle interactions are created with random quantum conflation patterns, but it will be a stochastic variation on the same general plan implicit in the complete fine-tuning of our current universe. So only particle data and the precisely tuned little program that computes their interactions are needed to create our entire universe. All the rest, the entire physical universe in physical space-time, is emergent and visible only to observers able to recognize the relationships among particles in aggregate. Ultimately, the entire universe consists only of the data of particles in a universal sea of existence called the quantum vacuum that brings the universe to life by computing their interactions. So creating a universe like ours is really quite simple, and we also discover an amazing new theory of everything in the process. Thanks for watching, and if you found this talk interesting, please let others know.